Hello everyone, this is Vijay, and today I'm going to talk about the one of the very interesting topic, that is system designing. A lot of companies these days they ask questions about system designing, and it is very important component of the interview process. Um, Mostly for the senior engineering role, and in fact the manager role also. Um, there are several things involved in the system designing questions. So let's talk about what are the basics of system designing. So system designing, what is system designing? And what is the so it system designing actually indirectly comes with the direct association with the distributed systems. And distributed systems are nothing but um, the computing resources. They are distributed into the different locations or different geographies, you can say. uh, it could be compute, it could be storage, it could be networking. So the very first thing starts with how a system is scalable, or how a system is reliable, how a system is available. So those are the three things mostly related with the system design question. And a lot of questions and argument are surrounded around those concepts. So there are three characteristic of distributed systems: uh, scalability, reliability, and availability. So scalability is like how much you can scale the system. Let's say you have 10,000 requests coming per second. If it is someday, because of your services hit, you get the 1 million requests, how you are going to scale to those many requests, and you can serve them on the timely basis. So that comes the there comes the scaling part. And you can scale the systems through two ways, like horizontal scaling and the vertical scaling. Vertical scaling, it used to be earlier, like you have a system, and you have three components: CPU, memory, and the storage. So you can scale this system by increasing these components on a single system. But again, it is limited to capacity of that system. So that is called the vertical scaling, and it has its own limit. Horizontal scaling is the important part, because we use the commodity servers, and we add all these host, or what you call the nodes, and form a cluster. So that is the basis of this distributed systems, where we do the horizontal scaling and add the different kind of host and form a cluster. And so the second part, we are talking about the three components of this distributed system. The second part is the reliability. So reliability is a when the system keeps on delivering the services, even though some of the components, software components or hardware components fail. So that is reliability. Availability it's a simple measure of percentage of time system is operational under normal conditions. One of the the caveat here is the reliability indicates the availability, but availability does not indicate reliability, right? So your let's say your retail um, online system, and you initiate or you start a system for initially, and it is operational for 2 years, it is available. But if you have not updated the system, there could be a lot of security vulnerabilities. So even though it is available, it might not be reliable, because there might be risks, and user data might be stolen or something like that. So uh, availability not necessarily means reliability. So one of the main component of the distributed system design is the load balancer. So load balancer, it's a component actually which can distribute the request from the client to the set of servers. So if we talk about load balancer, here in this figure, a lot of client requests are coming. Let's say you are online retail store, online shopping store. So a lot of requests are coming, and those requests have to be forwarded to the appropriate servers. I mean, there are different algorithms to route the requests. Sometimes we see which server is busy. Sometimes we see which server has a lot of connections and the fewest connection. So based upon the algorithmic complexity, we forward that request to the different servers. And load balancer could be at any level. So client request, let's say client request is coming for the first time, it would be there could be different web servers. So which web server has to be passed that request, it is decided by the load balancer, and then again after the web server, it could be application server also, or there could be application servers and the web server different setup, suite of clusters. So again, load balancer comes and it forward the request to the appropriate databases, because databases could also be busy, or there could be master and slave. People put different requests for the read and write. So uh, based upon that, load balancer takes care of that thing. Now the question comes, how load balancer knows, there could be another server here which might go down DB3, right? So if this goes down, how if the request is supposed to be for DB3, how it would decide? Um, so there's a mechanism by which load balancer keeps on checking the each server's health check. So health check is a mechanism by which load balancer already knows which server is good, and we can forward the request to that particular server. So in system designing, caching is one of the main component. So caching is something, it is based on the locality of reference principle. The data which is recently accessed is likely to be requested again. So that is locality of principle. So if you have application, you have cache, and you have the database. So directly, there are three components involved in any read and write operation. So first thing, you can go with, you can write into the cache, and then you can write into the database. So and caching is applicable in the hardware, OS, operating system, web browsers, web application. There are different components in almost everywhere caching is used. So the idea is to reduce the latency, because you can access the recently accessed data and frequently accessed data. So there are two choices. We can create the global cache or distributed cache. So we might have heard the term content delivery networks. So that is nothing but it's a caching mechanism, and the daily in our daily life we use a lot of online services. For example, Netflix. So Netflix, they use a content delivery network to distribute all of their media or the movies to the different parts of the world. So they use uh, caching. Another name is the content delivery network. So these are the set of networks, and they are in the different geographies, like proxy servers, and they are sitting, let's say, Asia Pacific, and there might be some server in the US, some servers in the Europe. So basically, for every request, you don't need to go to the actual source of data. You can access the data near to your location. So that is the idea of the content delivery network. And there are a lot of other companies, the third party companies, they provide this service, like Akamai, um, CloudFront, I guess. So caching is one of the thing, and when the caching comes, then there are three mechanisms to keep the cache coherent with the actual database. Because if you change something, something is changed on the data, this should be coherent to the cache, and in other terms, they should be consistent. So the process of invalidating the cache is called the cache invalidation, and there could be three kind of um, mechanism through which we do the cache invalidation. One is the number one is the write through cache. Uh, so basically, application writes to the cache, and the cache writes to the database. So basically, they are in coherent, and they are consistent. So whenever the power failure comes in any one of the system, so they all are consistent. The one drawback of this system is um, because they are consistent, and you are writing for every write, you are doing the two write operations. So it's a there might be a high latency. In the write around cache, you actually bypass this cache, and application directly write to the database, and then cache would be updated later after certain interval of times, or based on certain conditions. So one drawback of this system, as we can see, that there might be read operation for certain element, and that might not be in your cache, because you are not that has not accessed from the database. So that the term we use called the cache miss. So in that case, there could be cache miss. So application would be then directly going to the source of truth, or the backend database, and picking that value, and writing it to the cache, and then application. So again, this write around cache would also be can involve the high latency. Write back cache is actually you write directly to the cache, and then later on you write onto the database. So as we can see that it's pretty fast, because you are just writing quickly to the cache and coming, you return success to the application. But there's another drawback, though it is fast, that in case of power failure, uh, suppose you write something onto the cache, but you don't get time to write onto the database, and this power is this connection is down, so you cannot write that data. So that's there might be data loss in that situation. So that comes the cache invalidation. And when we talk about the cache, there's a cache eviction policies also, because this cache is a limited amount of memory. So how much data you can put on the cache, and so recently accessed or the popular data should be into the cache. So there are different mechanism to evict or remove the data from the cache. And so these are the first in first out. The first in data must be evicted, and the last data LIFO is when the last uh, access data should be removed. And we know all this term for first in first out, last in first out, least recently used, MRU, least frequently used. So these are the cache eviction policies, and these are the different algorithm we use to evict the cache.